Welcome back to The Explainer. Today, we're going to completely shatter the mystery of the Egyptian pyramids. If you've ever stared at these massive structures and thought, seriously, how on earth did they pull that off? Well, you are absolutely in the right place. But listen, we're not going to sit here and talk about magic or lost civilizations. No way. Instead, we're diving straight into the pure, grounded physics and the honestly mind-blowing logistics that actually made these ancient wonders possible.
Let's kick things off with this anchor thought directly from our source material. The pyramids are evidence of planning, not magic. I love that. Because if you really want to understand the pyramids, you don't start with the mystery, right? You start with the stone. Building a pyramid isn't about some inexplicable wonder. It is a massive, highly visible logistical problem. Every single block had to be quarried, shaped, moved, counted, placed, and aligned.
And since it's a logistical problem, we kind of have to reframe how we look at the whole thing. Instead of asking how they did something magical, we really need to ask this crucial question. What kind of system can move massive objects using just human hands and simple tools? It's all about applying highly organized human intelligence to raw physical resistance. That is the actual problem we are solving here.
Moving into Part 1, the 5 core forces, physics and project management.
Okay, so let's dive into this by breaking down the sheer physical challenge into the 5 immutable forces the builders had to manage. To truly wrap our heads around the scope of the problem, we have to look at weight, distance, height, organization, and precision. Think about it. Weight means managing massive friction. Distance requires mastering transport flow. Height? Well, that means fighting gravity. Organization turns absolute chaos into productive work. And precision prevents compounding errors. The source material points out something really fundamental here. A giant stone sitting in a quarry literally does not care how important your project is or how much of a hurry you're in. It only responds to the physics of these 5 forces.
Let's zoom in on distance for a second. When we talk about the force of distance, think of it this way. Moving one heavy box isn't really the main issue. If you've ever moved to a new house, you know the real problem is the full energy-draining chain of packing, loading, unloading, and then getting everything into the exact right room. A stone is relatively easy to handle if it's only moving a few feet. But for a pyramid, man, materials had to travel from the quarry to the river, down the river to the site, and then from the site all the way up the structure. Distance creates cost.
Which brings us to Part 2, a chain of solutions. Overcoming the physical barriers.
Now that we understand the physical problem, that the builders were constantly battling weight, distance, and height, let's look at how this builds into an ingenious, orchestrated chain of ordinary solutions. First up, how do you handle the immense friction of weight? A massive stone resting directly on the ground creates incredible resistance. So to overcome this, builders placed stones on sledges, basically low wooden platforms, and they likely poured wet sand in front of them to change the friction. This is brilliant because it transforms dragging a rough, unpredictable block into pulling a heavy suitcase with wheels. The load is still super heavy for sure, but the effort required to actually move it is suddenly way more controlled and manageable.
Right, and then there's height. As the structure rises, you obviously can't just slide the stones anymore. To solve the problem of ever-increasing height, without modern cranes, mind you, they used varied ramp systems. This effectively trades an impossible vertical lift for a manageable push over distance. It is exactly like pushing a loaded wheelbarrow up a gentle hill instead of trying to hoist it straight up onto a roof. The hill still takes energy, absolutely, but it dramatically redistributes the work.
The Egyptian builders didn't just rely on one magic trick for the whole build. They expertly adapted their methods across distinct layers of problem solving. First, you have quarrying, to actually separate usable blocks from the earth. Then transport, to move that massive stone horizontally over long distances. Next comes ground placement, where accurate measurement is absolutely everything to set the foundation. Finally, the rising stage, focusing on getting those stones higher via ramps, followed by final shaping to keep the geometry completely consistent. See, real engineering consistently adapts to the specific stage of the build.
Let's shift gears to Part 3, the site as a machine. Organization over force.
Okay, so here's the thing. None of those physical tools, the sledges, the wet sand, the ramps, none of it works without the most crucial, overarching technology the Egyptians had at their disposal: extreme organization. A lot of people picture ancient construction as thousands of people just randomly dragging stones through the open desert. It wasn't like that at all. The building site was organized precisely like a modern factory machine, made out of clear routes, storage areas, and highly synchronized timing. You had dedicated storage areas for stone, specific staging places for lifting, and kept clear transport routes. If pads were blocked, the entire flow would just grind to a halt. The site itself was a carefully designed production zone.
And woven right into that organization was a ruthless demand for alignment. Precision protects the whole project. This wasn't just some ancient obsession with making things look pretty. As the massive structure grew higher, tiny errors in the base would multiply into catastrophic leaning. Constant measuring and local reference points were a strict structural necessity. Basically, if your first row is off, your top layer is totally doomed.
What's genuinely fascinating is how all these pieces perfectly lock together. Sledges reduce friction. Ramps reduce vertical lifting. Teams reduce chaos. Measurement reduces error. Staging areas reduce wasted movement. They weren't trying to conquer physics. They were simply working with it to reduce every possible point of resistance into an extraordinary system. No single part of the project is magical on its own, but combined, they create a highly efficient machine.
Wrapping things up with Part 4, why it still inspires. Disciplined intelligence at scale.
We've gone from wondering how a mystery was possible to clearly seeing the system that made it possible. The real marvel here isn't aliens, or some lost supernatural civilization, or a magical miracle. No, it is disciplined human intelligence, careful planning, and ordinary actions repeated brilliantly thousands upon thousands of times. The monument is a towering testament to the fact that when manpower is organized into repeatable tasks, humans can do the absolutely unthinkable.
And honestly, this changes how you view the world. The mystery hasn't disappeared, it's just become intelligible. So, the next time you look at a massive monument, a modern skyscraper, or even a really complex project in your own life, you no longer just ask, wow, how big is it? Instead, you have to ask, what invisible system of small managed decisions will you discover making the impossible entirely possible?